So this next one is from chapter 7, and this is really now looking at membranes. I will tell you that actually I think the new edition does not have this, which surprised me, but I do want you to be aware of what we're looking at. So when we look at membranes, we know they're complicated. You can see when we did the cellular communication, we're showing you all kinds of different things hooked on. So we want to kind of up our game a little bit. But when we talk about a model is typically something that is a representation, usually a simpler representation of what exists. So we're gonna do that now. What's been removed from the newest edition is the Davison-Donnelly model. I've still seen this on standardized tests. I don't know if the new standardized test will eliminate this, but this is the old model of what they thought a membrane looked like. They had a phospholipid bilayer in the middle, and then there was a protein sandwich, kind of the breads on the outside. And we know that this is not right, although, like I said, it still shows up on some standardized testing. Okay, what you do want to know is what we're calling the fluid mosaic model. And that's more what you're seeing on the right. So I want you to think about what fluid and mosaic means. A mosaic is something made up of a bunch of pieces. And so what you need to know for a membrane is really 4 major pieces. So I want you to know what those pieces are and what they do for the membrane. The other one is fluid. And I want you to realize fluid means it moves. And so although we always show these pictures like they are here as this very static structure, reality is it's not like that. All of these things are moving. Now, some move faster than others. Some don't really move that much, like some of the bigger proteins are attached to the cytoskeleton, so they really can't move. But it is possible. And so I wanted you to keep that in mind when you're looking at the model. Now, the picture that comes up now that is mostly used is this one, like here. It's getting more and more complicated if you go back to the old editions. And so here, what you do is you have all 4 parts kind of showing up here. You have the phospholipid bilayer, which you can see. You have the proteins, these big purple blobs, and we'll talk about those. And then you can see these things in the green, and these, and actually this diagram finally got it right. I'll tell you the older editions of the names on some of these were incorrect, or at least the way they were, the names were right, but the way they were pointed were wrong. But anyway, so what we're looking at here are carbohydrates, and they have a function. And then the last one, which is kind of hard to see on this picture, but they're kind of stuffed in here, and that would be the cholesterol. So those are the 4 major components of a membrane. And so what I want you to kind of figure out is, kind of like everything, big picture, function. How do they help the cell? What are they used for? All right, so what we're going to do is on this one, we'll talk about the phospholipid bilayer and cholesterol. And the next one, we'll do proteins and carbohydrates. All right, so the phospholipid bilayer, what you need to know is, again, they have the hydrophilic head. Hydrophilic means water loving. And then they had a hydrophobic tail. Now, these are phospholipids. So if you remember that these are a type of lipid, obviously, and instead of a triglyceride, if you remember a glycerol with 3 fatty acids, this was a glycerol with 2 fatty acids, and then a phosphate group attached to it. And so what you're looking at here is the 2 fatty acids hanging down those tails are hydrophobic. And so amphipathic is a term I want you to know, and that term means that it has a water-loving side and a water-hating side. Lipids have that, and actually the proteins have that. And so what you're seeing is the head here is immersed in the blue, which is supposed to be the water, and then you have this area hydrophobic where it blocks the water out. Okay. So I guess function-wise, I should talk about that. And the function of the phospholipid bilayer is to be selectively permeable, or semi-permeable is another term we use. Selectively is probably a better term. But it regulates what goes through the lipids. If it can't get through those lipids, then it stays out. And obviously there has to be another way in, and that's what proteins are for. But this is kind of the wall. This decides what can get in, what can get out, what can get out, what doesn't get in, and what doesn't get out. So that's really kind of, and the other thing is structure. Most of the structure of the membrane is going to come from this phospholipid bilayer. All right, we'll talk about fluidity. What happens is we talked about unsaturated and saturated fats. Unsaturated fats have that double bond, so they have these kinks, these tails that bend. And what that does is it allows for those phospholipids to be a little bit more fluid. And then what happens is if it's saturated, they're tightly together. And again, they're holding the fluid out maybe a little bit better, and they're stiffer. All right, now cholesterol actually is kind of a strange thing. When we think of cholesterol in our diet, it clogs up our arteries. But reality in a membrane, cholesterol actually helps with the fluidity, helps it keep it moving. It doesn't let the phospholipids pack in real tightly. It leaves a space. And then what happens also when they get heated up, it actually holds them together and keeps them from breaking apart. So I want you to think of cholesterol kind of the opposite of what it does to our circulatory system. It actually keeps an animal membrane fluid. And just to let you know that this can be changed. I don't have it on here, so I do want to talk about it. What you're seeing with these phospholipid bilayer is they can actually move around. These are actually moving. We have them, tightly here, but if you think about like you have a bunch of matchsticks or something in your hand, you can kind of roll them around. They'll move, although they'll stay together. I want you to know they rarely will flip. It has been done. They've done it. It's under very rare conditions because to flip, to go from one side to the other, you have to expose those fatty acids to water, which they don't like. So very rarely does that happen. Okay, and so that will stop that section.